We'd like to solve this system of equation by matrices. So notice I wrote a matrix of the coefficients. The first column, coefficients of x's. Second column, coefficients of y's. Third column, constants. And now let's solve by rewriting this as an equivalent matrix so that there are ones along this diagonal, zeros below the diagonal. So notice there just already happens to be a 1 here, and now let's move to this element. I'd like to make this a 0. To do so, I'll multiply this element by -2 and add to this element. And I need to do that all the way across. The first row remains the same, but notice the second row. -2 times this element plus this element, -2 times this element plus this element, and -2 times this element plus this element, which is -5. All right, so let's rewrite. First row is the same. What do we have here? We have -2 times 1 plus 2. We have 0 like we want. This is -4 plus 5, which is 1. And this is 2 minus 5, which is -3. Now, it just so happens that, okay, this was already a 1. I made this a 0 by this work. It just so happens that this is a 1. So notice I have 1s along the main diagonal, 0s beneath. Had this not been a 1, whatever this number was, I would divide through by that number. Divide the second row through by that number. But notice I have it in the form I want, so let me go ahead now and convert back to equations. This is x plus 2y is -1, and this is 0x plus y, so it's y is equal to -3. And notice what happens here. You can already see the y value of the ordered pair solution. How can you get the x value? Let y be -3 here, solve for x, and you'll find that x is 5. This is the ordered pair solution of the system.